Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. So we start with Al-Fatihah. Okay. So with regards to this one, this is not actually on the diabetic reactor sangat lah. Okay, because this one you to assume the temperature. Okay, the one we discussed on during our lecture is to calculate the temperature, but this one the temperature is given here. It's not given, there is a range of temperature. So the temperature range is 950 to 1550. Okay, so you have to choose your own three final adiabatic temperature. This is actually a sample of the final assessment during ODL. Okay, so the question is quite different from the normal face-to-face question. So these three temperature you have to select lah. Okay, you have to select. So if I want to choose 950 degrees C, 1000 degrees C, 1550 degrees C, so it is within the range. If I want to choose 950, 951, 952, okay, it is also okay, but you can see the difference, not much difference if you choose this temperature, because here you go to the question, you are required to sketch. Yeah, you are required to sketch. You bigger the scale, then you can get the pattern lah. Tapi it's better for you to choose the an appropriate range lah. Okay, so this range is actually because it is open question, so we do not want student to do to have a same answer. Okay, during the final, because if the range is 950, 1550, we won't expect every single student to choose this value. Okay, for sure there is a range of temperature selected. All right, so this one you are given the flow rate 250 mol per hour of propane. The conversion is 80%, and then you are to evaluate the percentage excess of the air. Okay, percentage excess of the air. All right. So from your temperature, you will have a different excess air, the percentage of excess air. All right. So the drawing is there. The unknown, this is the flow rate of the air, and this is the flow rate of the nitrogen, oxygen, the unknown. Okay. So first thing to do is you have to recall our energy balance for non-reactive or for reactive. So the first thing to do is you have to solve the material balance. So if you go here, solve the material balance, it's already there, but you have X, Y, N. So if you refer to this, if you have so if you refer to that, you have what? Three unknowns, and then you will add another one unknown F, your excess, your percentage excess. Okay. Assume it to be F lah. Don't confuse it with conversion. Conversion also in the book they use F. Okay, so solve the material balance, done. Okay, number two, you have to it's not really done actually, the material balance, so I show you. Now the CH8, the propane in the outlet is 50. Now dealing with percentage excess of air, you remember you need to find the stoichiometric. Okay, you need to find the stoichiometric. So and And oxygen stock. I use oxygen because you can use air, but we still giving you the same answer. So and stoichiometry of the oxygen, we start from the limiting reactant 250 of the propane. Okay, refer to the equation or the reaction. 1 mole of propane, you have 5 mole of oxygen. So you got 1250 mole of oxygen. So this is required in the reaction. Now is in excess. Okay, and then if 250, if 80% conversion, calculator. Siapa ambil calculator macam dia? Una ambil calculator. So you got this 1250. So this is, let's say, this is the formula for our excess. It is N of the oxygen fat minus the stoichiometry 1250 over 1250. Okay, so if you simplify this, you got 1 plus F times 1250. Okay, so that one oxygen fat, you know, here in the air you got 0.21 N of the oxygen, you got 0.79 N of the nitrogen. So this N oxygen fat here is actually 0.21 N, 1 plus F. Because at the end from our table, outlet at inlet enthalpy table, we only want to have one unknown, which is the F. Okay, the rest two should be, replaced or must be substituted with other formula relating the F. So 0.21 N is here. So if you want to know 0.79 N, okay, so what to do? You divide this with, if you want to know 0.79 N. So 1 plus F, 1250. I guess you need to multiply with, ini matematik ni, simple matematik. 0.79 N. Okay, you need to know the N first lah. Okay, you need to know the N first. So let's say our N is 1 plus F, 1250 divided by 0.21. 4702.38. Okay, 1250 divided by 0.21. Sorry, 5952. Sorry, 0.4. So to get 0.79 N, to replace the water, to represent the air, so 0.79 multiply with that N here. Okay, so you got here 4702. The line is dah makin ciput dah ni. 4702.38. 38, 1 plus F. Okay, saya mention je 1 plus F here. It's not there to, untuk saya dah tulis. Okay, so now settle on the inlet, the N. Now your N is already being represented by the F. No more N lah, so F. Okay, now actually there are many other ways to solve this, so I'm showing you one of the way lah. Okay, so next we go to the X and the Y. Okay, Y is actually nitrogen. Y is nitrogen. So nitrogen, the flow rate is still the same because nitrogen doesn't involve in the reaction. So you got nitrogen 4702.3832 1 plus F. This is for nitrogen. Now for oxygen, coming out of the reactor, which is your X, okay, what can you do? The simplest way is you solve atomic balance. So I show you O balance. You solve atomic balance. Yes? O balance, O in your inlet will be from the oxygen in the air. So 2 times 0.21 times N equal to your oxygen will be in your CO2, 2 times 600 plus 800 plus 2 times Y. 2 times 600 plus 800 dekat water plus 2Y. Okay. So from there, you will got this one actually can be replaced with the one for the oxygen asal-asal tu. 0.21 tadi what we got? 1 plus F 1250 equal to 1200 plus 800, it will be 2000 plus 2Y. So from there you simplify to got Y. So your Y is supposed to be what? 1 plus F okay, kita kena ada equation. Dia tak dapat a direct value of the flow lah. 1 plus F 1250 minus 1000. Minus 1000. Slow lagi. Okay, sorry lah. 1000, okay, whatever the value, 1000 there. So from after that, okay, before solving, okay, we go to the table dulu lah. We go to the table so that we can have a clear idea what to calculate actually. Okay, so we prepare the table. I'm showing you heat of reaction method. You can solve using heat of formation method. Okay, no harm to use that. But this one given from the formula from the answer here, the lecturer using heat of reaction, because in the question it's not stated what method can you use. So you can use any. So again, the same question or the same pattern of question will be asked in the final assessment this semester. I'm not giving you any method, so you choose your own. Okay, because this is open. So since it's open, then we require you to use your own method lah. Okay, in fact it will be you know, I will guess the solution will be varied because some of you may use HOR, some of you may use HOM. So I'm the one to mark that. So agak confusing. Okay, bukan agak confusing, banyak. There will be many answers lah. I can't have one answer scheme. And then for your information, this question actually a rubric kind of question ni actually 12 marks je. It is actually 12 marks. It is a rubric kind of question. So bila rubric, so as I already discussed with all of you, you have the content and then we see whether you fulfill the content or not. So for example, detail of calculation, or to be specified, maybe the enthalpy calculation. Every single enthalpy, the calculation of every enthalpy is shown. So if you shown and correct with a correct value, itu number 5 lah. Kalau shown but with a wrong value, then mungkin duduk bawah 3 or 4 punya range. Okay, so this is rubric. So this is HOR. So the reference state will be all the reactant and product lah. So C3H8, gas, oxygen gas, nitrogen gas, what else? CO2 gas, water gas. So you put here C3H8, solve it using our normal procedure of energy balance, oxygen, nitrogen, CO2, H2O. So this is not here in the reactant. So this one H1, H2, H3. So the value here 250. Okay, oxygen, you put that with the F. So oxygen actually in the feed is 0.21 N, which is 1 plus F times 1250. Nitrogen, 4702.38, 1 plus F for the nitrogen. For the C3H8 at the end, so 50, this is 600, the water is 800. So the oxygen is Y, the nitrogen is X. Okay, so if you want to replace this, X is 4702, is the same value of the inlet. And then the oxygen, from our atomic balance tadi tu, you got 1 plus F, 1250 minus 1000. Okay, so you put here H4, 5, 6, 7, and 8. Okay, so you show how to calculate the H1, H2, H3. So it's supposed to be H1, H2, H3 adalah 0 because reference state. Okay, it's reference state. Right, 25 degrees C. Now for the outlet. Okay, for the outlet, you have to select the temperature, adiabatic temperature. So let's say this first table, you assume the T adiabatic as 1000. I follow the solution, 1000 degrees C. So from 1000 degrees C, you have to integrate this from 25 to 1000. You have to use the CP from table B1. Okay, so you got the value, whatever the value. I'm showing you the method. So the detail of the solution too, you can write by your own. I give you the idea. H5, you can go to table B8. H6 also table B8. 7 also B8. H8 also table B8 because it's all gas and your reference state is also gas. Okay. So what to do next? You write the energy balance equation. Okay, if you write the energy balance equation with all these 0 because adiabatic. So you got delta H, your delta H is supposed to be external reaction multiplied with the heat of reaction plus outlet. Minus equal to inlet, but now your inlet is actually 0. So this one 0. Now from this formula, you need to calculate the external reaction. So we use any of the components. So to be secure, kita gunalah propane as the component. So remember the formula to find the external reaction. N of propane in the product equal to N of propane in the feed. It is a reactant, so minus external reaction. So in your product is 50, in your feed is 250. So your external reaction is 200. So next you calculate heat of reaction. Use the simple, it's not the simple lah. The heat of formation of the product minus the heat of formation of the reactant. So you will got negative 2044.02. Okay, so what to do next? This one you are showing only for one adiabatic temperature, 1000. Okay, and then next you should put all the value, the acceleration 200, heat of reaction 0, negative 0.2044. This one, the outlet is here, 50 times this one, 50 times H4, this one H5, H6, H7, H8. and then you equal to 0, then you notice that the only unknown that you have from there is actually F. So from there you should get your F as 1.034. 034, which is equivalent to 103.4% lah. 103. Very slow line. Okay, 4%. 103 and 4%. Okay, so you need to repeat this for the second assumption of your T adiabatic, and also the third example, assumption of your T adiabatic. So my suggestion is that you repeat the table, giving your assumption of the adiabatic temperature, because now your enthalpy will be different because different temperature. So you put out the mass flow rate doesn't matter, the molar flow rate is still the same. It's just that now H4 until H8 will be different. So you put that in a proper table. So for, let's say, the solution here, the lecturer using the second one, she's using T of 1300, the third one 1500. Okay, so this one he got 46.3%, and this one 21.5%. So you have to it's not that giving me this value only. It's not about giving me the value only. You have to show back how you, as I advise, you show back your inlet outlet enthalpy table here. Okay, giving your adiabatic temperature. Okay, it should be detailed lah. It should be detailed. Rubric ni we require you to give a detailed calculation. Okay, then only you can get 5 out of 5. Okay, so you give the different value of the enthalpy, and then for the third assumption pun you give the table and then give the enthalpy. Okay, so no need to repeat the energy balance equation to no need to repeat that only for the first one. But the table too, I will always advise all of you to repeat the table. Okay, with respective the adiabatic lah. Okay, and then the last question asks us about the sketching. So we do the sketching. So it's supposed to be here, sketching. So since you have the value, so you put the value here. And this one 1000. So for this one you got 21.5, here is 46.3, here is 103.4. So you write here is T adiabatic, this is your excess. Okay, so the clue normally for lecturer to see whether your calculation is correct or not, you got that pattern lah. If you got that pattern, means that your calculation tu maknanya correct lah. If you got wrong pattern, anda tahu kau dapat pattern macam ni, so we know that your calculation is wrong. Okay, so any question? Before I proceed to the next question. Any question on this? No question. All right, thank you. All right. So now we go to this thermochemistry of solution. Okay, this is quite an interesting question. It's not that about the reaction, because this reaction is actually what we discussed during our lecture. Okay, the reaction. But here you see heat of formation technique. If you go to the textbook, the method shown is only heat of reaction. Okay, but here is heat of formation technique. So it's a very good discussion lah, so that you have an idea how to solve using heat of formation. Okay, mungkin semua dah dapat dah kot idenya. Alright, so now the A is actually present the flow chart of the above process, and then you are required to solve the mole balance and then calculate the R and then solve using heat of formation. Okay, so I guess untuk flowchartnya simple as this lah. Right, you put the temperature, you put the ni, I want to change it to C, nanti confuse dengan belakang punya AB. Okay, so put all the unknowns or that, since this one is what, 3 marks, 5 marks. Okay, the present chart is actually 5 marks, so you have to give this flow rate, the composition here, you have to put it correctly lah. And what most important is actually you put the temperature lah sebenarnya kan, temperature. Ataupun you can mention here is solution. Kita boleh kata Na2SO4 aqueous. Boleh jugalah, whatever lah. Tak tulis pun tak apa, is known. Now solving the material balance, we solve using atomic. So we choose S balance, Na balance, H balance. Okay, so this is our C. C is our NaOH stream. And then N1 is your Na2SO4. N2 is your total water in the product, whether obtained from the reaction or within the aqueous of Na2SO4 too. Okay, remember as what I discussed in our lecture. Okay, so the R now for the H2SO4, NaOH, and for the outlet. Okay, so since all of them are in mole, so you just simply divide that, so you got the value. So this is all the R. And then for the Q calculation, you give the reference state. So since this is heat of formation, heat of formation. So I use the element. So you got hydrogen, natrium, sulfur, oxygen. Okay. So as what we discussed, we never split the N and the H for thermochemistry solution. Okay, we never do this lah. Okay, using heat of reaction method, while we do not split that, we can't see clearly. But during heat of formation method, using heat of formation method, you will understand why actually the N and the H cannot be splitted. Okay. The clue that I gave earlier in our lecture, because H2SO4, you have what? You have two components here. Okay. H2SO4 liquid and H2O liquid. Then only you can have H2SO4 aqueous. Okay. So during heat of reaction, you can't see clearly, but for heat of formation, you can see it here. So we go to the heat of the H2SO4 first for the A. Okay, so A actually, okay, so I go here then, right? Because I also have A here. So A, because now you need to form the compound, you need to form the compound. So you need to form the heat, you need to form the H2SO4 liquid, the pure solute, and also you need to form the water. Then only you can have the solution. So here, this is the flow of the H2SO4, 20. So in order for you to form the solution, remember the formula. Heat of formation of a solution is heat of formation of the solute plus heat of solution. Okay, this formula. Okay, so this is for H2SO4. H2SO4. All right, so H2SO4, this is the heat formation of H2SO4 liquid from table B1 plus heat of solution. Okay, heat of solution for the H2SO4 using table B11, this one using table B11. Okay, and then you add you add with heat of formation of the liquid water. That's why we need to multiply with 80. Because again, this is because the formula is kilojoule per mole of the solute. Kalau more solid, more solid, more solvent, more solvent. So that's why you need to multiply with that respective flow rate of that component. Okay. So 2080. Okay, so you got A as negative 40174.8. Now you repeat for B. So now for B, 40 is for the NaOH aqueous, and 93.33 is for the water. Okay, so here you need to form the NaOH aqueous first. So it is solid, NaOH solute plus with the heat of solution. So you got this value. And lastly for the C, no integration CPDT, because this is all at 25 degrees C. And then for C, it is 20 for the Na2SO4. Heat of solution is actually can be assumed 0. This one you can assume 0. And then for the water is 213.3. Okay. So once you form that, you got the value, and then you put into the energy balance equation. Negative 4744.22 kilojoule per minute. Okay, so that is the way to solve using heat of formation method lah. Okay. So any question? Any question? If no question, then we will stop here.
No, Doctor.
No, all right. So that's all for today. Thank you very much. You can try to solve the first question. Please try to solve the first question. If you have any doubt, any difficulty, you can ask me back. Okay. So thank you. Assalamualaikum warahmatullahi wabarakatuh.
Salam tadi, Doktor.
Waalaikumsalam.
Ya,